we want to find our indicated compositions and then also give the domain. So for this first one, we want to find f of g for the functions x squared plus 4x minus 5 and 3 over x. Okay, now notationally, sometimes the text will list f of g without indicating the independent variable. So I think it's better for you though if you think of that as f of g of x. This does not mean multiply by x. It just means, like here, x is the variable that we're going to use. Okay, so definition of composition, this means f parentheses g of x. And now start on the inside. So we just want to put in what is g of x, and g of x is 3 over x. Now to simplify what's left, into the function f, instead of a regular x, we need to put in 3 over x. So my tip here would be to put parentheses around all of the x's and only the x's in the function f. And now to evaluate f of 3 over x, all we have to do is replace what's in the parentheses. So this is parentheses 3 over x all squared plus 4 times parentheses 3 over x minus 5. And there's a little bit of simplification we can do here, not much. When we square the fraction, we have to square both the numerator and the denominator, so that becomes 9 over x squared. Remember, 4 is the same as 4 over 1, so when I multiply, I get 12 over x, and then just a minus 5. Now, we've also been asked to give the domain of this composition. With domain, there are two things to look for: variables in a denominator or variables under an even root. And here we definitely have variables in a denominator. So the way to find the domain when we have variables in the denominator is we take the denominator, or in this case maybe we need to think denominators, and set them not equal to 0. Now if you watch what happens here, this denominator is x squared, and if I just start with this one, I need x squared to not be 0. In order to break this down to be just x, I'm going to undo the square with the square root, and I get down to x cannot equal 0. I should remember a plus minus when I take square roots in general, but plus or minus 0 is still just 0, so here it's not going to make any difference. Now that's simplified to give me x cannot equal 0, and if I look at the next denominator, it was x. So to solve this portion of the domain, I would take that denominator x and say it's not 0, and I'm going to get down to this exact same answer either way. So my domain is all numbers except for 0. Now part B, I'm using the same functions, but the order of the composition is reversed. So this time I want g of f of x. So definition of composition, that's g parentheses f parentheses x. That now becomes, replacing the f of x in here for our parentheses, we get g of x squared plus 4x minus 5. Now that's a lot inside of our parentheses, but it doesn't matter. That means I'm going to put this in place of the x in the function g. So again, if it helps, put parentheses around just the x in the function g, that outer function, and now change what's in the parentheses. 3 divided by, put parentheses if you want, it doesn't matter, x squared plus 4x minus 5. But notice I'm not multiplying or dividing this by anything, so those parentheses aren't really doing anything, and I can just write that as 3 over x squared plus 4x minus 5. Now once again, I also need the domain. I only have one denominator this time. It's the quantity x squared plus 4x minus 5. For my domain, that cannot be 0 because we can't divide by 0. Now this is a quadratic. This one will factor into x plus 5 times x minus 1. And if I want the product to give me something other than 0, that means each of the individual factors cannot be 0. So we get x plus 5 is not 0, or x is not negative 5, and x minus 1 is not 0, or x is not equal 1. And this is the domain, I probably should label it, for our second composition.